So we've talked about systems of linear equations, but we can also have a system of linear inequalities. All right, so we're usually going to solve these by graphing in each inequality and determining the regions of overlap. So if we'll remember, if you recall, whenever you graph an inequality, you have to shade above or below the line. When you graph systems of inequalities, you end up with a section that is overlapping each other. And that overlapping part is the part that is the solution to the graph. So a solution to a system of linear equalities is the set of all values that make the inequality true. So when we graph the inequalities, that a solid line will indicate that the line's included in the inequality, and a dotted line means that the line itself is not included. Alright, so there are several steps to solving a system of linear inequalities. We always solve these steps. So first, graph each line that is a part of the system on the same coordinate grid. It is very helpful to graph each inequality by using a separate color. So if you graph one in blue and you graph the other in red, you'll be able to really see the shading really well. So you want to graph a solid line if the inequality is less than or equal to or greater than or equal to, since that's going to indicate the solution includes the line. You're going to graph a dotted line if it's just less than or greater than. Choose one point on the graph. If that point makes the inequality a correct statement, color all the points on that side of the line. If that point makes the inequality an incorrect statement, color all the points on the line that does not include the point. The region that has both shades, so where the colors overlap, that's the solution for the system of inequalities. These two points right here, we didn't really talk about last time, because what we said is that if it's less than or equal to or just less than, we're going to shade below the line. If it's greater than or equal to or greater than, we're going to shade above the line. By choosing a test point like these do, you can algebraically prove that the part that you're shading is the correct part. So here's some examples. So to solve the system of inequalities, and this is a system of inequalities, this little notation here is just a bracket saying that the system goes together. It's nothing super important or change in mathematically of how we've been doing things. So we've got y is less than or equal to 3 and x is greater than or equal to -2. Since the two inequalities both contain the or equal to signs, we're going to graph the lines y equals 3 and x equals -2. So you're just graphing those two lines using a solid line. Okay, you graph each line on the same coordinate grid, indicating which line is which, trying to use different colors. So if we look at this one, this graph right here is the line y equals 3. And this graph right here is the graph of x equals -2. So when x is greater than -2, I'm going to shade in that light purple color everything that's greater than -2. For y is less than or equal to 3, that's below the line, so that's going to be everything below it. Where the two colors overlap, that is the solution to the set of inequalities. Okay, so where the two colors are. So this is the example of using a point. So choosing 0, 0 with the inequality means that 0 is less than 3, so that's a true statement. So we're going to color where the point 0, 0 is. And they did the same thing with the other one as well. Alright, so now we have a different system of inequalities. These aren't straight lines anymore. This is y is less than x plus 3, and y is greater than -2x plus 1. So we've got the less than, okay, instead of less than or equal to. So we're going to graph this line right here, that y equals x plus 3, but we're going to use a dotted line instead of a straight line. The second one has a greater than or equal to, so we're going to do that exact same thing, treat it just like an equal sign, y equals -2x plus 1, and we're going to use a solid line this time. So to graph x plus 3, I start at 3, and I go up 1 and over 1 all the way up my graph, and then we're going to use a dotted line here. To graph -2x plus 1, I start at +1 and I go up 2, but to the left 1, and use a solid line there. Since this first one is y is less than, I'm going to shade below my line, and this is y is greater than, so I'm going to shade above my line. If you'll see, this actually makes 4 different quadrants. It makes this one here, which is not a solution to either of them. This light pink quadrant here is a solution to only one of the lines. This purple quadrant is a solution to only one of the lines. But this quadrant over here that has both colors mixed together, this is the solution set for both lines. So here's where they choose a test point. So they choose 0, 0 again. In the first one, 0, 0 is a true statement. So that's why 0, 0 is included in the shading. For the second one, 0, 0 is not a true statement, so they colored on the other side of the line where 0, 0 is not. So the solution set of inequalities is the set of all points that are both colors. Again, I'm not so worried about this right here, as long as you can remember that if it's greater than, I shade above, and if it's less than, I shade below. And then where they overlap is the solution set. So this is the worksheet that we're going to work on in class, and it's got 2 problems on it. So the first one is solve the system of inequalities. So here we've got that x is greater than or equal to, or excuse me, y is greater than or equal to negative x plus 2, and y is greater than 2x minus 1. So for this one, I've got that or equal to sign, so I'm going to make sure to use a solid line. For this one here, I'm going to still treat it just like it were an equal sign, but I'm going to make sure to use a dotted line. Both of them are greater than, so for both of them you'll end up shading above. And then I'm going to let you give number 2 a try in class.